Happy Monday! Today we are going to be covering finding the equation of a line through 2 points, which we already did a little bit last time. But this time we're actually going to also be checking for the x and y intercept and what that really means graphically. So I will be exploring some of the graphs below. But to start us off, I'm going to start with this idea of having Hannah's race. They've given times for Hannah and then distances that she's traveled in meters. And we're trying to find the equation of a line. So I'm going to go through that. I'm going to use the points 1410 and 2814 in order to build the equation of a line. So I'm going to switch over right now to my piece of paper so that you guys can see my work and how I would do this. Give me 1 second. Okay, so switch over here first. And then I'll go back to the CPM example. So we have Hannah's race there. So I would use the points 1410. So 14 is how long she's traveled. 14 seconds, she's gone 10 meters. And then I would also use one of the other points. So I'm going to use 28. In 28 seconds, she's gone 14 meters. So we're going to try to figure out the rate that she's traveling. In order to do that, I need to figure out the slope. That's the same thing as the rate of travel. So I'm going to take my m equals, and just a quick reminder, we take our y's, the difference in our y's. Like how much do we travel on our y's first? Over our difference in our x's. So I'm going to take my y difference. My y difference, I'll go 14 minus 10. I could have done 10 minus 14. It just matters that you use the same point. So if I did 10 minus 14, I would have to come back here and do that over 14 minus 28. So instead, I'm going to choose this point. So I'm going to do 14 minus 10. Those are my y's, right? 14 minus 10. And now I'm going to subtract my x's, but I have to come back here since I use the 14. So I do 28 over 28 minus 14. The change in my y's over the change in my x's. So here we have 14 minus 10 is 4. I have 28 minus 14. 28 minus 14 is 14. So on here, we do have to reduce this. We ask ourselves what number goes into both 4 and 14. Well, 2 can go into both of them. So I'm going to reduce this so that we can see the actual rate reduced. 2 goes into 4. 2 goes into 4 2 times. And 2 goes into 14 7 times. Our rate of change is 2 over 7. What that would mean in context is this, in context of this is that she's traveling 2 meters in 7 seconds. That's really how this is. This is meters over seconds, meters over seconds. So here we have that she's traveling 2 meters in 7 seconds. Okay. From here, we now are going to find the equation of the line. Well, we know that the equation of a line is y equals mx plus b. Y equals mx plus b. So what we're going to do here, is we're going to now plug in our slope because we have our slope. Y equals 2 over 7, 2 meters per 7 seconds, x plus our b. The problem is we don't have this yet for the equation. Like we learned before, we can plug in one of these points. It doesn't matter which one. We can plug in one of these points and then we can solve for b because these points work in this equation. So that's what I'm going to do. I'm going to choose the smaller point, but you can choose either one. And I'm going to use that and plug it into here to solve for b. So I'm going to plug in 14 for my x. Okay. And I'm going to plug in 10 for my y. So what I have here now is 10 is equal to 2 over 7 times 14, and you can think of that as 14 over 1, okay? Or it can just be 14. And then I have plus my b. There's a couple ways to do this. You could go ahead and in this one to simplify, 2 times 14 is 28, and then you can divide that by 7 to get 4. Or you can think of it as, well, 7 goes into 14 2 times, and then 2 times 2 is 4. But regardless, we get 4. So what we have is 10 is equal to 4 plus b. Well, I want to get b all alone. That's kind of the goal here. So I'm going to subtract 4 from this side. And we end up with 6 is equal to b. I now have the equation to my line because now I have b. I have the slope, I have the y-intercept. My final answer is y is equal to m, which we already know is 2 over 7, x plus 6. And there is the equation of our line. Okay, so that's the first part of, whoops, I didn't mean to do that. I wanted to change my video. Just 1 second here. I'm gonna switch it to this. And now what we're gonna do is we're gonna look at a different, so we already did that. I know a lot of that is review for you guys, but I wanted to go over one of those examples. We're gonna kind of take it a step further. So I'm gonna get into the 2.23, and we're going to look in here at our y and x intercepts and how we find those. So what we're gonna do right now is graph one of the lines. I'm gonna actually go to Desmos at this point to graph a line where we can actually look at the x and y intercepts. So let me get into here. I'm gonna go to desmos.com, just like you guys would do. And from here, I'm gonna hit, whoops, I missed the S, desmos.com. I'm gonna hit the graphing calculator and I'm going to put in the equation of a line. Let me put in the equation y is equal to negative 3x, and let's go plus 3, just to give a nice line here. Well, looking at this, if I asked you guys for your x and your y intercepts, I gave you some pretty nice ones here. It looks like my y-intercept is right there. What I want you to recognize is that in a y-intercept, and I'm actually going to write this down, this is good for your notes, I would write down that your y-intercept is when your x is equal to 0, and I'll show this in a minute. Okay, so that's a big concept and big takeaway. It's where your x is equal to 0. Your x-intercept is going to be when your y is equal to 0. When your y is equal to 0. So that's going to come into play here. If you were just given the equation of a line, and I'm sure you guys can see it mathematically here. You can see what the equation of the line is. It's negative 3x plus 3. But if I didn't give you the equation of the line and I asked you to figure out what the x and y intercept is, this is how we would do it. So I'm going to go ahead and again switch my video over so you guys can see what I'm doing here. Okay, so if you know that for your y-intercept, it's where your x is equal to 0, if we have the equation y is equal to negative 3x plus 3, all I would do to figure out where my y-intercept is wherever there's an x, I plug in 0, because we know that it's 0. So I would have y is equal to negative 3 times 0 plus 3. That would mean that y is equal to negative 3 times 0 is 0 plus 3. I get positive 3. Now, if you guys really think of that, of course it would be that. Isn't this just your y equals mx plus b? Isn't that your y-intercept? So if given the line, then you should know that your y-intercept is right there. The less obvious one, though, is your x-intercept. So again, given this whole y equals negative 3x plus 3, if I asked you what your x-intercept is, what you're doing is you're plugging in 0 for y. You're plugging in 0 for y. So we have 0 is equal to negative 3x plus 3. I'm going to add my 3 to the other side, and I have 3 is equal to negative 3x. To solve for x, I'll divide by the negative 3, and I end up with negative 1, which means that so I get negative 1 for x. It means that my x-intercept is negative 1, 0. Oh, I'm sorry. You know what? Look at there. I did not subtract the 3. I needed to subtract the 3. It's positive 1. Positive 1, 0. From here, you subtract 3, so it would be negative 3 over negative 3 is positive 1. Positive 1. And we can see in our graph that that is the answer right there as well. Positive 1 and 0, 3. Okay, so I'm going to do one more example, but I'm actually going to do the one from your homework. So I'm going to come over to your homework, and you are asked for, on which one is it? The slope and y-intercept. Okay, so that one. Am I looking at the wrong module? Yes, I'm looking at module 3. Give me a second. I had module 4 open, and here's the module 4 assignment. So on module 4, on tonight's work, you have this one right here, where it asks you, what are the x and y intercepts given this graph? Well, let me zoom in just a tiny bit more. It looks like it's pretty obvious to find the y-intercept, but the x-intercept doesn't look to be as nice. That doesn't look to be as nice. So what I want to do first is find the equation of the line. So that's what I'm going to do. I'm going to start by finding the equation of the line. So it looks like the points that I see on here, I'm going to pick 2 points on here. I'm going to pick the 0, 1, because that's a nice point. 0, 1. 0, 1. That's a nice point. But it doesn't look like it's a nice point through the x-intercept. So I'm going to go down here to this point. That looks like a nice point. And that point is at 1, negative 1. You could have also used a point up here if you wanted to, but I'm going to use this one. So I'm going to go 1, negative 1, because that's a nice point that it goes through. So now, after that, I'm going to go ahead and use the same 2 things that I've done on the last sheet of paper. I'm going to find the slope first. So I have m is equal to, I'm going to do negative 1 minus 1, negative 1 minus 1 over 1 minus 0. I end up with negative 2 over 1, which is negative 2. So I've got my slope. So now I have my slope, so I have negative, or y is equal to negative 2x plus b. I now need to find this right here, this y-intercept. You might recognize that this is the y-intercept. So it should be 1 here, but I'm going to plug in the point just to be sure. I'm going to plug in 1 is equal to negative 2 times my 0 plus b. This is just 0. Negative 2 times 0, anything times 0 is just 0. So I actually get b is equal to 1. So that makes sense. It goes in line. It makes it so that way I can kind of double check to make sure I've done it correctly. And I get y is equal to negative 2x plus 1 as the equation of my line. Okay, so when asked for my y-intercept and x-intercept, I know that the y-intercept, you can see it. Okay, so my y-intercept should be 0, 1. It should be 0, 1. But for my y-intercept, the big idea is that I'm going to plug in x equals 0. So I'll do that really quick. I have y is equal to negative 2 times 0 plus 1, which means y is equal to 1. I don't write y equals 1 for my y-intercept though. It's a coordinate point. It's where x is 0 and y is 1. That's really important. It's important to note that you would write it as a coordinate point. This is my answer. Now I need to find my x-intercept. That's the one that doesn't seem so obvious here. My x-intercept is where y is equal to 0. My x-intercept is where y is going to be 0. So that's what I do. In my equation, I plug in 0 for y instead. 0 is equal to negative 2x plus 1. To solve this, I'm going to subtract 1 from this side. So I have negative 1 is equal to negative 2x. To solve for x, I'm going to divide by negative 2. And I end up getting x is equal to 1/2. Again, that's not how I write the final answer. I write the final answer as 1/2 for my x, comma 0, because it's where y is 0. That is my final answer for my x-intercept. If you look on here, it kind of does look like that's where it would be. So that confirms it for me. I can tell graphically that that's probably correct. So those are my x and y intercepts, and this is my line. So for A, you guys are done. That's what you were finding for A. Actually, it's this equation, okay, the plus 1. And then for B, your answer is 0, 1 and 1/2 0. Okay, you have a couple more that look like that as far as finding the equation of lines. And that's about all for today. Kind of review a little bit new with the x and y intercept thing. I will see you in my Zoom today if you guys are interested in coming this morning from 9 to 10. And if not, I'll see you on Wednesday or in class. Have a great week.